Hello everyone, this is Dr. Rajesh. I am again with you with my next video lecture, and the topic is angle of intersection between two surfaces. So in this we will the concept we have discussed in the last lecture in details we have discussed. So in this we will be only dealing with an important question, and I think this question may be there in the examination this time. So this question we will deal with, and we will see how it is done. So the question is, find constants a and b so that the surface this will be orthogonal to the surface this one. So firstly I am going to write the surfaces at this particular point. So firstly I will write the surfaces. And surfaces first is ax square minus byz minus a plus 2x equal to 0. So the second surface is 4x square y plus z cube is equal to 4 at point of intersection 1 minus 1 2. Now comparing it with this one, phi x y z equal to c1 phi 2 x y z equal to c2. This could also be written, if you want, you could write it something like z cube minus 4 equal to 0. So here it could be phi 1 x y z is equal to a x square minus b y z minus a plus 2 x phi 2 x y z is equal to 4 x square y plus z cube minus 4. Let us say this is the surface number 1, say surface number 1, and this is the surface number 2. This, you may say that this is 2, this is 1. So the normals at this one is, say this, say n1, and normal at the second one is, say this one, n2, and these are given to be perpendicular. So we have to find, and this is the point of intersection where we are finding the normals 1 minus 1 comma 2. Say this is point P. Now we have to find the normal. So normal along this surface will be given by del phi, gradient of phi 1. So this will be, so we need to determine del phi 1. So it will be 2ax minus a plus 2 I cap. It will be minus bz j cap minus by k cap. Del phi 1 at point 1 comma minus 1 comma 2 is equal to 2a minus a minus 2 I cap minus 2b j cap plus b k cap. So this is further equal to a minus 2 I cap minus 2b j cap plus b k cap. Say this is n1. Fine. Say this is n1. So this will be this one. So we have, and this will be named as number 3. Similarly, determine del phi 2. So this is the your phi 2. So we have to determine del phi 2 I partial differentiation with respect to x, 8xy plus j cap 4 x square plus k cap 3z square. Del phi 2 at point 1 minus 1 2 is equal to I cap. It will be minus 8 plus 4 plus k cap. It will be 3 into 4, it will be 12. So this will be equal to minus 8 I cap plus 4 j cap plus 12 k cap, and name it as equation number 4. So now we see, since surfaces cut at orthogonal at point 1 minus 1 2, therefore their normals at point 1 minus 1 2 are perpendicular to each other at 1 minus 1 2, because we know that angle between the surfaces is equal to angle between their normals. If surfaces are intersecting at 90 degree, then their normals will automatically be intersecting at 90 degree. So their normals will be at 90 degree, means that theta angle between them will be 90 degree. Therefore we use the definition of dot product n1 dot n2 dot is equal to n1 mod n2 mod cos of 90 degree. Cos of 90 is 0. This implies that n1 dot n2 is equal to 0. Implies from equation number 3 I am going to put the value of n1, okay, and from equation number 4 I am going to put the value of n2. So, and this must be 0. This implies that, now take the dot product, minus 8 a minus 2 minus 8 b plus 12 b equal to 0. This implies that minus 8a plus 16 minus 8b plus 12b equal to 0. This implies that minus 8a plus 4b plus 16 equal to 0. This implies that, taking minus 4 common, so this will be 2a minus b minus 4 equal to 0, implies 2a minus b is equal to 4. So this is equation number 5. Now see, we have determined one relation, and the relation between a and b, and that is given by equation number 5. But to solve the equation in two variables, we need two equations. So we will be this is point to be noted. To solve this particular problem, we need another equation. So how will this equation come? Now look at the problem. Problem states that this is the point of intersection. If this is the point of intersection, it will be laying upon both these surfaces, surface number 1 and surface number 2. If it will be laying upon both the surfaces, it will also be satisfying their equation. So it will also be satisfying the equation of surface number 1. It will also be satisfying the equation of surface number 2. So if it will be satisfying the equation of surface number 1 and 2, so I am going to write here, since 1 minus 1 2 is point of intersection of both the surfaces, therefore this point 1 comma minus 1 2 will satisfy equation of both the surfaces. And we know equation of surface 1 is given by so what is the equation of surface 1? It will be ax square minus byz is equal to a plus 2x. This is the given equation. You can again have a look at it. This is the equation number 1. Okay, so that we have written So we will be taking this, and point 1 minus 1 will satisfy, so I am going to put the point a b minus 2 is equal to a plus 2. This will be 1. This implies that a plus 2b, a plus 2, this will cancel out. This implies that 2b is equal to 2, implies b is equal to 1. Now look at the equation number 5. Equation number 5, from 5 2a minus b is equal to 4. Put b is equal to 1. This will be 4. This implies that 2a is equal to 5, implies a is equal to 5 by 2. So this is the value of a, and b is equal to 1. So these are the values of constants a and b. So this question is very important from the examination point of view, and I feel this could be there this time in the examination, and most of the time these questions do come in the examination. In this we have to find the value of a and b. One condition was very clear, that angle between the normals was 90 degree. Second condition, it is a tricky one, because that is the point of intersection, and point of intersection is laying upon both the surfaces, and if it is laying upon both the surfaces, it will satisfy their equation, and if it will satisfy their equation, it will be giving us another condition between a and b from equation number 1. So this is very important question from the examination point of view. This is all I have from this lecture, and if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying you goodbye. Take care. Bye bye.